We're going to continue working through examples of verifying trig identities. Once again, we have our three ideas up here. We want to choose the more complicated side and make it look like the less complicated side. To do that, we will use identities that we have, factoring, distributing, adding fractions, maybe some other algebraic ideas. And then we also noted sometimes it's helpful to think about what the less complicated side is equal to. If we usually get that if we kind of get stuck. So number 17, we definitely have the more complicated side on the left side. So let's see if we can simplify that. In the past, I've mentioned if we have squared terms, it's also often helpful to use the Pythagorean identities, or at least see if they're applicable. I don't have any squared terms, but I do notice right away that this is in the form a plus b times a minus b, and we know a plus b times a minus b is a squared minus b squared. So let's go ahead and distribute here. When we multiply out, we'll get a squared, which in this case is secant squared theta, minus b squared, which is tangent squared theta. And we're thinking that will be equal to 1. And what we did there, we just distributed. Next, I do see some squareds, so I'm going to look at the Pythagorean identities. In a past, or maybe a couple past examples, I would kind of manipulate this using algebra and put it in a different form. This time I'm not going to do that because you don't have to do that. You can use it in the form that it's in. I'm going to show you that here. So we see down here on the right side that secant squared is equal to 1 plus tangent squared. So I'm going to take out the secant squared and put in 1 plus tangent squared theta. And then we subtract tangent squared theta, and we quickly see what's going to happen here. So that was using a Pythagorean identity. And we just subtract, and we get 1 is equal to 1. So we could say we add like terms, subtracting here. So 1 equals 1. Okay, number 19. It's a little more challenging. Both sides do look a bit complicated. So we can pick the one that's more complicated. Some people would probably say the fractions are more complicated, and I can agree with that. That's fine. So let's start with the left side. And what sticks out to me, so I'm just trying to give you some hints and clues along the way how to think through these. Our right side is 2 terms. It's tangent theta minus 2 secant theta. Right now, the left is only 1 term, but we have a denominator, and so we could think of that cotangent is a common denominator of both terms. So I'm just going to separate this into 1 over cotangent theta minus 2 cosecant theta over cotangent theta. And what I did is I just used the common denominator there and separated it into 2 terms. One other reason I thought that was going to be a good idea is because this first here term is tangent theta, and I know that 1 over cotangent is actually tangent theta. And so that was also, that's a good idea that it might, that might be a good idea to change that. So that's what I'll do now. I'll go ahead and use that reciprocal identity, knowing, let's see if we can find it on here, reciprocal identity, knowing that tangent theta is 1 over cotangent theta. So we have 1 over cotangent, and so we're going to write that as tangent. So this is tangent theta, and that's using a reciprocal identity. Well, at the same time, I notice I have a 2 and a 2, so that's good. So what I want to do now, cotangent, I know also has to do with tangent. I know there's some quotient identities that have to do with cotangent. So I'm going to come down here and I'm going to look at cotangent, box it in here for you, is equal to cosecant over secant. And I think that's going to be helpful because maybe some things will cancel. So I'm going to change that denominator. This is going to look pretty complicated as we write it because it's going to be a compound fraction. But using that one I just boxed in, that's cosecant theta over secant theta. And so that was still a reciprocal identity. So I used reciprocal identity twice there. Oh, no, I'm sorry, that wasn't reciprocal, that was quotient. Now, we don't have to show this work. We can kind of just show the next step, but I'm going to show you what I'm doing here. I'm going to multiply the top and bottom by the reciprocal of the denominator. So this is another side trick. You guys know that you can simplify fractions this way, but so over here this cancels. And in fact, over here this also cancels, so the cosecant cancels with the cosecant up here. And actually that's, now we're set, we have what we want. So this is tangent theta minus, if we look close after all those crossouts, we have 2 secant theta, which is what we wanted. And what we did, we just simplified our compound fraction, is maybe how we can write that. So when we have a compound fraction, in order to simplify that, we can multiply both the top and bottom by the reciprocal of the bottom. And then let's look at number 21 here. Sine of theta plus cosine of theta cotangent theta equals cosecant theta. Well, don't have a real great starting point here. We have 2 terms on the left, 1 term on the right. So what we can do is see if this equals something. And so maybe this is a time where we change everything to sine and cosine. And also number 3 up at our, at the top here, I had this third idea. I mentioned the sine and cosine thing, but let's at least keep in mind that this cosecant theta, that's 1 over sine theta. So if we can get to 1 over sine theta, we're basically there. So let's change everything to sine and cosine. So we have sine theta plus cosine theta times cotangent. Well, cotangent right here is cosine over sine. The one that we should know is tangent is sine over cosine, so cotangent is the reciprocal of that. And these are the ones that kind of end up working themselves out, as we will probably see here. So we don't want that whole denominator. So cosine over sine. Now, I'm going to try to show most of my steps here. Now I'm just going to multiply here. So this is cosine squared over sine. Write what we did here. So this was using a quotient identity. Hopefully I have enough room here. Quotient, and then next we just multiplied. Now what I'm going to do is, my right side is just 1 term and my left side is 2 terms. So in order to get that to be 1 term, we're going to go ahead and add those. To do that, we get a common denominator. And now, once we think through this, you might start seeing where things are going to kind of shape up here. So we're going to get a common denominator and add. So really we have sine squared plus cosine squared. once we have this common denominator, sine squared theta plus cosine squared theta over our common denominator of sine theta. So that was a common denominator. I have to slide down a little bit here. What's sine squared plus cosine squared? We've seen that a few times. We see some squared terms. That should remind us of Pythagorean, and we know sine squared plus cosine squared is equal to 1. So we have 1 over sine of theta equals cosecant theta, and that's kind of actually what I reminded us at the beginning, that 1 over sine theta is cosecant theta. So we just use Pythagorean identity, and to squeeze it in here at the very bottom, we know 1 over sine theta is cosecant theta. So our last line says cosecant theta equals cosecant theta, and that was using a reciprocal identity.